Welcome to this Broadcom course series on Automic Automation's cloud integrations. Here we focus on the Kubernetes integration. In this overview, we'll address the broader aspects of the integration before delving into specifics in later modules. For now, our objective is to make sure that students understand the reasoning behind the Kubernetes integration and the benefits to the users. One of the basic responsibilities of Automic Automation is to orchestrate operations across multiple environments, including the cloud, and synchronize these processes with on-premise workloads, say in ERPs. With Automic, we're able to centralize process automation configuration and then trigger, monitor, and supervise all in one place. Kubernetes workload can then be synchronized with the rest of your operational environments, databases, ERPs, and operating systems. Containerized applications require process automation like any other, and Automic provides native support for those requirements. You should be able to describe the Kubernetes integration and explain how it works. Fundamentally, Automic is performing the exact same service as on-prem. It's just the targeted environment that is different. The integration is entirely consistent with Automic configuration methods. We describe all the component parts of the integration. Setting up Automic with Kubernetes means deploying an agent you obtain from Marketplace. It creates a number of template connection and jobs objects, which we use to connect to the environments, trigger processes inside of pods, supervise execution from start to finish, and finally retrieve job reports. Our purpose is to build a gateway into the Kubernetes environments so as to trigger processes against applications in the clusters. It's really no different to operations managed locally, other than the cloud context. As always, we're able to synchronize with conventional applications, database, and system operations. One of the more significant benefits to this approach is we don't have to have host automation tools and dedicated containers, although this is possible. If you need help with this, please refer to our Automic Automation Kubernetes Edition course. In the end, it means supervision and support can be assumed by the ops team. The integration comes in the form of a package which we download from Marketplace. It contains an agent with the standard Automic configuration and startup procedures. As soon as the agent connects to the automation engine, it adds new templates to the repository, connection objects to connect to the appropriate namespace with proper authentication, and jobs objects designed to trigger the processes. Each time we need to trigger a job or process in Kubernetes, we simply create a new Automic job. When the Kubernetes job runs in Automic, it triggers various types of processes in Kubernetes, monitors status evolutions, and finally generates a job reports. We're able to run jobs directly in a pod, from the code repository, and even scale applications. This job can be added to a conventional Automic workflow, so it's part of an orchestrated process involving other applications, say a database, an ERP, or some other system. We start with a hypothetical scenario involving two systems, the Automic Automation host and a dedicated system for the agents. The agent is configured with a simple INI file with the values you'd expect: system, agent name, connection, TLS, and so forth. We start the agents with the ucxjk Java command. As soon as it connects to the engine via the JCP, a number of template objects are created, 2 connections and several jobs. One CONN enables the connection to the cluster, while the other CONN is needed for executions from the source code repository, say GitHub. Then let's assume we have 3 distinct clusters and 1 source code repository. These host applications in different namespaces. In the Automic job definitions, we target the namespaces. For each cluster or repository, we need to create a connection object in Automic. We use the CONN templates and duplicate it as many times as we have instances, in this case 4. In the case of a conventional job, we also have several methods for authentication. In the case of the repository, we need an additional CONN object to authenticate, assuming the file is protected. If this file is unprotected and publicly available, then the SCM connection can be left blank. Lastly, we create K8s jobs in Automic. We have 3 main process types: K8s, container scaling, and command type processes. The Automic jobs include the single or dual connection objects based on the target system and the type of process. If the job is located in a repository, then we may need the SCM connection depending on the level of security. We're able to retrieve the successive statuses and generated job reports. In Automic, these jobs can be incorporated in workflows and integrated with other non-cloud processes. We touched briefly on the benefits of running Kubernetes operations from Automic. As we mentioned earlier, Automic can be containerized, although it's not necessary. The integration works just as well with on-prem Automic. First, Automic is fully integrated with the Kubernetes technology and can support process automation from start to finish for all containerized applications. Teams responsible for supporting Automic require absolutely no knowledge whatsoever of Kubernetes or the cloud. Some of the challenges associated with such an environment are entirely handled under the hood by the integration package. For ops teams, it's entirely transparent and managed like any other agents. Automic also supports source control repository platforms like GitHub and SVN, including authentication when necessary. Whether you're running baseline processes or processes from the SCM, again, it's transparent for operations. The integration provides several methods for submission. All formats are supported: YAML, JSON, file formats, as well as commands. The definition method is slightly different and each will be covered, but the handling of the execution is the same. The integration also allows running the command in the running pod. We also provide a simple process for building container up and down scaling. You simply define the job, set the number of containers, and executes. Finally, there's the organizational factor. In every organization, the ops side of the business has a dedicated team, and they know their jobs inside and out. As such, cloud operations can be added to their portfolio fairly seamlessly. For them, it's transparent. Cloud teams should not be on the hook for handling the ops side of the Kubernetes business. They should focus on writing jobs and not manage on-call schedules, escalation procedures, middle-of-the-night crisis management, and more generally, any sort of supervision.